Assalamu alaikum, dear students. Welcome to Mathematics Online. In this lecture, we will be discussing some exercises based on functions, and in particular, the types of functions. So the first question here in exercise number 1.2 is that show that the function f from this is r subscription star to r star defined by f of x is equal to 1 by x is 1 1 and onto, while r star is the set of all non-zero real numbers. The question is further that is the result true if the domain r star is replaced by n with codomain being same as r star. So let's see how to solve this question. We have to check whether this is 1 1 and onto, and after that the domain is changed and codomain is kept as same. So the question can be solved like this. You see here, it is question number 1 of this exercise. We have solved it here. So the given function is f is a mapping from r to r star to r star defined by f of x is equal to 1 by x. For 1 1, what we do, we take two points in the codomain, that is f of x is equal to f of y. Okay, these are the points in the codomain. For if they are equal, then what we have 1 by x is equal to 1 by y, because f of x is equal to 1 by x, therefore f of y is equal to 1 by y. So they are equal. Taking the reciprocal as x and y, they are not equal to 0. Therefore, x is equal to y. So if this is equal to, these 2 points are equal, this means that same codomain images actually are the reflections of the same domain points. Okay, hence f is 1 1. So next is onto criteria. For onto, let's do one thing. We take a point in the codomain, say it is y, and for that we have a corresponding point in x. Suppose that there exists a point x such that 1 by x, x is equal to 1 by y, that belongs to r star. It's clear that y is not equal to 0 because r star contains only non-zero real numbers, such that f of x is equal to, now we will take the f of x. F of x is equal to 1 divided by what's in terms of the definition of f of x is 1 divided by x. So it is 1 divided by x. Instead of x, we will write 1 by y. Okay. So it is 1 by y. So taking the reciprocal, we get y. So f is onto. So this function is also onto. So it is 1 1 and onto. That's its objective function. Now let's change the domain set. Instead of r star, we'll take n. So g of x is equal to 1 by x. Once again, we will take g of x1 is equal to g of x2. That again implies x1 is equal to x2. So it's 1 1. So the next is we will check its onto criteria. For that, we will take one point in the codomain set and check whether there exists an image in the domain set or not. So let's take 1 by 1.2 fractional point in the non-zero set of real numbers, and for that we will check whether there exists any x such that g of x is equal to 1 divided by 1.2. So there does not exist, because there does not exist any natural number that's of the form of 1 divided by 1.2. Hence, it is not onto. So on changing the domain of the above function, it does not remain onto. Same are the questions here. We have here changed domain and codomain, and we can see the solution, how we can solve this exercise on the same line. This is homework for you. You may solve these questions. Okay. Next is question number 3. We have to prove that the greatest integer function f from r to r given by f of x is equal to greatest integer function is neither 1 1 nor onto, where this is the greatest integer less than or equal to x. So the question is, f is a mapping from r to r, set of real numbers to real numbers, and it is given by f of x is equal to greatest integer function. It seems that let's take any point in the see domain set, it is 1.2. F of 1.2 is equal to greatest integer of 1.2, that's equal to 1. F of 1.9 is equal to 1.9, greatest integer, that's equal to 1. So you see that f of 1.2 is equal to f of 1.9, but 1.2 is not equal to 1.9. What does that mean? That means it's not 1, 1. For the onto, what we do, we take 1 point, say 0.7 in the codomain set. We see that f of x is equal to greatest integer is always an integer, but it never gives 0.7. So there exists the fractional points in the codomain set that are not mapped to any element of the domain. So hence we conclude that f is not onto. Hence the greatest integer function is neither 1 nor onto. So you have so many questions here, just like your modulus function and other questions. You try your best to solve these questions. If you are able to solve these, then it's okay. If not, you can ask in the comment section. I will be more than happy to answer your queries. Thank you for joining the class. Thank you once again.